Hi, I'm going to do a video or two on how to graph things if they are in the vertex form. This is going to be using the homework that I assigned to my A block class, and it is this homework assignment where you have things put into the vertex form and you have to graph them. So I'll do a few of these and we'll see how it goes. Okay, we're going to start with the first one. The first thing that we want to remember with the vertex form is it is in this format here. So we have y equals a, which is kind of the steepness or how a measure of how uh, tightly squeezed up or spread out the parabola is. If a is a high number, it's going to be stretched up and squeezed inward. If it's close to zero, it's going to be kind of a wide parabola. If it's negative, it's going to be downward opening. If it's positive, it's going to be upward opening. So that's one thing to know. And we have, of course, x minus h squared plus k. So we have a vertex point, which is going to be, this is basically a transformation of the basic y equals x squared. We have a vertex point, which is going to be at hk. So if we can figure out what hk is, then we can find our vertex. Well, in this case, h, the thing we're subtracting from x, is 4. Okay, so our x value is going to be 4. And our y value for our vertex, so instead of plus k, we have minus 3. So that's the same as plus negative 3. So plus negative 3. Okay, so we can remember that that means that our k is going to be negative 3. So we have a vertex point at 4, negative 3. Cool. Now the next thing we can find out, take a moment and check and see if that makes sense to you. The next thing we can figure out, though, is our y-intercept. And now the y-intercept is what we get if x becomes 0. Okay, so we're going to go down here for the y-intercept information. I'm going to say we're going to replace x with 0, and then we solve the whole thing. So if x is 0, then that means that in here is negative 4. So we're going to square negative 4. So if we square negative 4, then we get 16, because negative 4 times negative 4 is 16. Then I'm going to go back and write this plus negative 3 as just minus 3. Okay. So now I'm going to have to use the order of operations. I do 2 times 16, which is 32. And I subtract 3 from that. And so my y-intercept is going to be at 29. So 29 is the y value when x equals 0. Now, I can find my mirror point, which is on the opposite side of the parabola for my y-intercept. My middle of my parabola is defined by the vertex. So the x value here is the middle x value of the parabola. So if I go halfway across the parabola, I've gone 4 places. To go all the way across the parabola, I've got to go 8 places. 2 times 4. So my x value there is going to be 8. And my y value is at the same level because the parabola is symmetrical. At this point, I just need to pick a couple of points that are in between. And I'm going to pick 2 for the x value and 6 for the other x value, because those are exactly 2 away in either direction from my vertex, so I know my y values are going to be the same because the parabola is symmetrical. So let's figure out, when we just have to plug in our input here. So I'm going to plug in my input of 2 here, and then that, and I also am going to plug in, I don't have to do this because I know the answer is going to be uh, the same because of symmetry, but we'll just do it just to make sure. So first thing I'm going to do is I'm going to do 2 minus 4 because that's in parentheses. 2 minus 4 is negative 2. Then I'm going to square negative 2, since that's the next thing in the order of operations. And negative 2 squared is 4. Okay. And now I'm going to multiply 2 times 4 because multiplication comes before addition and subtraction. So that becomes 8. And I have 8 minus 3. So I'm going to make clear that that is that. 8 minus 3. So I will have equals 5. So I have 5 here. So I have a point at 2, 5. Now this one should also get me 5. I'm going to make it clear that this is minus 3 because it might be a little harder to see. But let's sort this out. So here I'm going to have 6 minus 4 in the parentheses, which is 2. 2 squared is 4. And then 2 times 4 again is 8. And 8 minus 3 is 5. And yes, indeed, we get 5 for that point. Okay, let's plot these points. So I'm going to have a vertex at 4, negative 3. I've got a desmos here. It's going to confirm it. So 4, negative 3. Okay, go ahead and label that. I have a y-intercept at 0, 29. So I'll plot that. 0, 29. Then I have a mirror point on the opposite side at 8, 29. I can't see this right now, so I'm going to zoom out a little bit. My computer has a lot to think about because I'm making a video. And now I'm going to pick the 2 other points which were at 2, 5 and 6, 5. And now I've got my points. Confirm that that's the ones I wanted. Yep, those are my points. And now we'll plot the parabola here. The parabola was 2 times x minus 4 squared minus 3. And it matches. So we have our first parabola plotted nicely. Okay, let's try the next one, which has an extra little twist to it. It has a negative 1/2 as our a value. So I'm going to go ahead and remind ourselves that our a value is negative 1/2, but we also can figure out what our h and our k are. So in this case, our h is still negative. I'm sorry, our h, since h is what we're subtracting from x, our h is not negative 4, our h is 4. So we have an x value for our vertex of 4. And our k value is 3 because it's plus k. So we've transformed our basic parabola from 0, 0 to 4, 3. So we have a point at 4, 3. I'm going to go ahead and turn this off and go ahead and plot that. So that's 4, 3. Now we want to find our y-intercept. Now our y-intercept is what y is if x is 0. So we'll calculate that. So if x is 0, I can turn x into 0. X is 0, then I'm squaring negative 4 there. Negative 4 squared is negative 4 times negative 4, which is 16. And then I'm going to multiply 16 times negative 1/2. 16 times 1/2 is 8. But if it's negative 1/2, it's negative 8. So now I've got negative 8 plus 3, which is going to equal negative 5. So I have a, when x is 0, I have a y-intercept at negative 5. Now I'm going to go over to my mirror point. My mirror point is going to have the same y value, negative 5. I just have to figure out what the x value is going to be. Well, I can figure that out by going, okay, I'm going from 0 to my middle of my parabola, which is going to be at 4, x is 4. So if I go halfway across to get to 4, I have to go 4 more. Very convenient. We started at 0, we go 4, and then we go 4 more, which is 4 plus 4, which is 8. So I now have my y-intercept and my mirror point. Let's go ahead and plot those. 0, negative 5, and 8, negative 5. 0, negative 5, and 8, negative 5. Now, you might notice that this is shaping up to be a downward-facing parabola, which is what I expected. Okay, I am now going to put labels on those points. You can see them there. And now we will figure out a couple points in between. So once again, I'm going to pick a point that's 2 away from 4 in that direction and 2 away from 4 in that direction, 2 away on the horizontal. So I'm picking an x value of 2 and an x value of 6. So I'm going to plug in the equation here and here, and we will simply replace x with our input of 2. So we're using 2, and we're going to, on this one, we'll replace it with 6, and we just solve what we've got. So 2 minus 4 is going to be negative 2. And the negative 2 squared is going to be positive 4. Okay, now we've got 4 times negative 1/2. Well, 1/2 times 4 is 2, and negative 1/2 times 4 is negative 2. So I've got negative 2 plus 3, which equals 1. So I have a point here at 1. Okay, and we can predict that this will be 1, but we're going to solve it anyway, just to make that really clear. So 6 minus 4 is 2, and 2 squared is 4. And now negative 1/2 times 4 continues to be negative 2. And negative 2 plus 3 continues to be 1. So we have symmetry established again, and we have a point at 6, 1, and 2, 1. So we'll plot those. 6, comma 1, and 2, comma 1. And it looks very parabola-y. And we'll go ahead and plot the parabola. And there it is. It matches. Okay, and this one is a downward-facing parabola. I'm going to go ahead and turn this one on as well. Notice that this one is a doubled steepness, and this one is a halved steepness. So doubled, positive doubled is going up, and it's squished together here, whereas negative half is spread out, and negative, it's making it go down. I have a vertex here at 4, 3, and this one has a vertex here at 4, negative 3. Okay, we'll do one more. Now I'm going to skip 3 because 3 is more straightforward. Let's see if I can find one that's a little less straightforward. Keep moving through here. Number 10 might be a good one to do. Yeah, let's do 10 because it has a... Actually, yes, we'll do number 10 because 10 has a bigger A value. So on number 10, I'm going to go ahead and move it onto a page of its own. You can see what we're dealing with. So on number 10, I've gotten off of. Okay, number 10, I should say. Number 10, we've got our H is going to be 4. Our K is going to be negative 4 because that needs to be a plus K. So we're saying plus negative 4. So our vertex is at 4, comma, negative 4. All right. Now our y-intercept we'll find by plugging in 0 for x. So I'm going to figure out what y is when x is 0. And we'll just go through here and replace x with 0 and solve that. So 0 minus 4 is negative 4. And once again, negative 4 squared is 16. So it's negative 4 times negative 4 is positive 16. 4 times 16 is 64. And then 64 minus 4 is 60. So we have a y-intercept at 0, comma, 60. Now we look at our mirror point on the opposite side of the parabola is also going to have a y value of 60. And we're going 4 across again to get to halfway. And we have to go another 4 to get to the other side. So we go 8 to the other side. Okay. And I'm going to go ahead and pick 2 points. I'm picking 2 and 6 again because they're convenient. And we'll plug in our inputs of 2 and 6 and solve this. Okay, so if I plug in 2 here, and I plug in 6. So 2 minus 4 is negative 2. And negative 2 squared is positive 4. And 4 times 4 is 16. And 16 minus 4 is 12. So we have a point at 2, 12. I'm going to do the same thing here. You can predict that the y value will be 12, but I will confirm it. 6 minus 4 is 2. 2 squared is 4. And 4 times 4 is 16. 16 minus 4 is 12. And indeed, we have 12. So now we'll plot all these points. I'll turn all of this off. Get the labels out of there. And so we've got we have a vertex at 4, comma, negative 4. We have a y-intercept at 0, comma, 60. And we have a mirror point at 8, comma, 60. And we can't see those right now because 60 is off the screen, but there they are. And I'm going to leave it like that so you can see that it's all squished together and stretched up tall. It's a upward opening because we had a positive 4 as our A value. And then we have 212 and 612 to plot. 212 and 612. I highly recommend, as you're doing this by hand, that you come up with the points before plotting it because it'll help you plan what your scale is going to be for your parabola. Now we're going to go ahead and plot the parabola, which is this. So y equals that, and in fact it matches. So there we have some parabolas. All right, my next video I'm going to show you a sneaky trick that you can use once you have the vertex, and then you can actually plot your parabola without using the y-intercepts and the mirror points. There's another sneaky trick we can use. But for now, I'm going to pause this one.